Hi dear students, today I would like to explain distance and displacement concept from the motion chapter. See, this motion chapter is helpful for the engineering students. If you want to do the electrical engineer or mechanical engineer or electronics engineering, you need to know the mechanics part, nothing but motion. Motion chapter is very important. So here distance. Before knowing the distance, we should know what is meant by rest. Rest is nothing but if the position of the body does not changes with respect to time or surroundings, then the body is said to be at rest position. What is meant by motion? If the position of the body does changes with respect to time or surroundings, then the body is said to be in motion. A car moving on the road, a person cycling on the road. So you can take the example for the motion. And in this motion chapter, we have the terms related to motion. Main first will be distance, represented by symbol small d. The actual path covered by the body is nothing but distance. CGS unit of distance is centimeter, MKS or SI units will be meter. And distance having only magnitude, that's why distance is a scalar quantity. Scalar quantities are nothing but the physical quantities having only magnitude but not direction are called scalar quantities. And the dimension formula for distance is capital L, or we can write m power 0, L power 1, T power 0. Displacement, we can represent with capital S or small x. The shortest distance between initial and final point is called displacement. CGS unit will be centimeter, MKS or SI units will be meter, and displacement is a vector quantity. Vector quantities are nothing but the physical quantities having both magnitude and direction and also obeys laws of vector addition. Then only we can say those quantities are vector quantities. And dimension formula will be capital L. See, here if you observe this figure, the person is starting from A and reach to B in the different paths. Here from AOB one path, APB one path, AQB in one path. So we should take the distance is nothing but actual path. In which path he traveled, that path only we need to consider as distance. If suppose the person is traveling in the O path, nothing but AOB will be the distance. If the person is moving in the P, along with the P, we can take APB will be the path. And if the person is moving in the different curved paths, nothing but along with Q, then you can take AQB will be the one path. So in which path he traveled, that path we need to consider as a distance. Suppose coming to displacement. Displacement is nothing but what? Shortest distance or simply shortcut. Mainly the initial and final point is very important to find the displacement. If you observe this figure, initial point I took here, final point I took here. Suppose I given the arrow direction, that will be the actual path. From initial to O to final point will be the actual path. To find the displacement, we need to join the initial and final point. So this will be this path is nothing but shortest path. To reach final point, we can say this path is nothing but displacement. Coming to here, the person or any body is traveling from I to F. I to F. So I is the initial, F will be the final. So in the curved path he reached to F. Shortest distance we need to find. The shortest path is nothing but displacement. This will be the shortest path, right? So this is the shortest distance between initial and final point. Initial and final point is nothing but displacement. Now here they given the rectangle from A to B, B to C, C to D and D to A person or the particle, the body travels. So here in this case we need to find distance and displacement. Suppose if you observe DAB is nothing but distance from A to B. DAB is nothing but distance from A to B. A will be the initial, B will be the final. Distance how much we have? 4 kilometers. A to B will be 4 kilometers. DAC is nothing but the particle travel from A to B and then B to C. So A to B will be 4 plus B to C will be 3. 4 plus 3 how much? 4 plus 3, 7 kilometers. And A to D, distance from A to D, nothing but we need to cancel the direction here. A to B, B to C, C to D. 4 plus 3 and this distance also 4 kilometers. Why? Because in rectangle parallel sides are equal. So 4 plus 3 plus 4. How much? 11 kilometers. D A to A. A to A is nothing but A to B, B to C, C to D and D to A. We need to add AB plus BC plus CD plus DA. 4 plus 3 7, 7 plus 4 11, 11 plus 3. How much? 11 plus 3 14. 14 kilometers will be the distance from A to A. To find the displacement, here we need to apply the shortest concept, shortest distance concept. So A to B, there is no shortcut. We need to consider AB distance only, nothing but 4 kilometers. A to C. If you observe the figure, from A is the initial, C will be the final, A will be the initial, C will be the final. The shortest path we need to take this one. This is the displacement. To find the displacement, if you observe A, B, C, this is the right angle triangle. For the right angle triangle, we can apply the Pythagoras theorem. To find the longest side AC, we need to apply square root of opposite side square plus adjacent side square. You will get square root of 4 square plus 3 square. So you will get 16 plus 9 root 25. Root 25 is nothing but 5 kilometers. So this is the displacement we need to consider. And 5 kilometers in which direction? So direction means for the displacement we need to consider north, south, west, east. So this will be the northeast, this will be the northwest, this will be the southwest, this will be the southeast. Here from the figure, the particle is traveling from A to C. A to C, nothing but we need to consider northeast direction. Northeast direction. And if you observe this for A to B, direction will be A to B. A to B will be east direction. In east. Why? Because displacement is a vector quantity having magnitude and direction also. Coming to SAD. AD means initial point A, final point will be D. The shortest path we need to consider as like this. This is the shortest path. This is the shortest path. So A to D 3 kilometers. In which direction? Shortest path A to D. A to D in north direction. Right? A to A. A to A means initial point A, final point also A. So shortest path is not there. That's why you need to consider 0 kilometers A to A. Here for the circle, find distance and displacement for half revolution and 1 revolution. See, they given the radius value 7 centimeter. OA will be the radius here, 7 centimeter they given. The particle starts from A and it completes 1 revolution. For one complete revolution, we need to find the distance and displacement. For half revolution, nothing but at B, from A to B, also we need to find distance and displacement. Half revolution is nothing but, so we need to consider the semicircle. See, to find the distance for half revolution. For half revolution, we need to consider to find the distance as a circumference of a semicircle. Circumference of semicircle as the distance here. DAB is nothing but pi r. Why? Because full circle 2 pi r, half circle is nothing but pi r. Pi means 22 by 7 into r value of much 7. 7 will get cancelled. We got 22 centimeter as a distance. To find the displacement from SA to B. What will be the initial point A, final point B? So what is the shortest distance for A to B? So this is the shortest distance. Nothing but this will be the diameter, right? Diameter means 2r. So 2r. We need to consider the shortest path from A to B. Initial and final point we need to join, and we need to consider this will be the diameter. Diameter means 2r. 2 into r value will be 7. 2 into 7, 14 centimeters. Alright. Now for one revolution. For one revolution, nothing but from A to A. Here initial point will be A. After completing the revolution, again it comes to A. Initial and final will be same. Then you need to consider displacement. SA to A is 0. Coming to SA to B. Sorry, A to A. Sorry, we need to find out the displacement from A to A is 0. Distance from A to A we need to consider as how much? Distance will be one complete revolution means we need to take the circumference of circle 2 pi r. 2 into 22 by 7 into r value 7, 7 cancel, 2 into 22, 44 centimeter will be the distance covered by the body or particle after completing one revolution. But displacement is 0 for one complete revolution. For half revolution, distance is 22 centimeters, displacement is 14 centimeter. In which direction we need to consider? Left side direction is nothing but, again we need to draw directions, north, south, west, east. The particle is moving from A to B, nothing but left direction. We need to consider as west direction. So this will be the concept of distance and displacement. Thank you.